Hello, Integrated Math 1. Welcome to lesson 2.3.4. We're playing around with systems of linear inequalities now, right? So we're doing activities 4.1 and 4.2 today, which means we're starting off on page M2-205 in your workbook. We're picking up right where your getting started activity left off. So real quick, before we go to that getting started activity, before we pick up from that, I just want to mention one little thing. You have been graphing systems of you've been graphing systems of equations, right? You graph a system of equations. That's where the lines cross. That's where my solution is. You've been graphing more recently inequalities, right? We graph inequalities where we end up shading an entire half of the plane. The line has to be dashed or solid. But now we're dealing with systems of linear inequalities. So the inequalities become known as constraints, because the values of the expression are constrained to lie within a certain region of the graph. So now, instead of looking at, my lines intersect, their point is my solution, now we're looking for where our inequalities are creating a certain region of the graph. That's where all of my solutions are going to be, that my inequalities are kind of hemming it in and being like, it has to be within this section. So that's why they're called constraints. So let's come back to Chase and his river rafting guide days. So of course we came up with two inequalities, right? Because we said he can only have, at most, he can only have 800 pounds in that raft. That if you go over 800 pounds in the raft, bad things happen, people drown, boo, not good, right? And of course we also said that, this is a lot of work for him. So he'd like to be able to make at least $150 per trip that he does. It's a lot of work to put this together, right? And it's not worth it to him if he has to make less than that. Suddenly it's more work than it's worth. So we came up with two inequalities for that. Please remember that Chase is also in the boat, so you got to take him into consideration as well, which is why our inequalities end up looking the way they do. So here's what I'd like you to do. Let's consider two trips that Chase guides. I only have one on my page. You have both of them on your page. But we have two scenarios. A, first trip, Chase guides 2 adults and 2 children. And then B is the second trip where Chase guides 5 adults. So I would like you to determine whether each combination of rafters is a solution of the system of linear inequalities. Remember, solution makes the statement true. If you plug it in, it's not true, it's not a solution, right? And when we're looking at a system, we have to make sure it's a solution for both of the inequalities in our system. So once you've done that, you've decided, yes, this is a solution for the system, or no, it's not a solution of the system. Explain what the problem is, describe the meaning of that solution in terms of this problem situation. Why is it a problem or not a problem? Go ahead and hit pause to work these out, and then hit play when you're ready to check your work. All right, let's check out the first situation. Chase guides 2 adults and 3 children, but remember, Chase is an adult and Chase is in the boat. So that means A does not equal 2. It means A equals 3, because Chase is in the boat too. There's 3 adults in the boat and 2 children in the boat. So we're going to plug in a 3 for A and a 2 for C on this first one. So 200 times 3 plus 100 times 2. 200 times 3 is, of course, 600. 100, and make a little note of that there. 200 times 3 is 600. I want my pen. 100 times 2 is 200. So 600 plus 200 puts us right at 800 pounds, which is less than or equal to 800. I mean, I know we're cutting it close, but this is a solution for the first inequality. Let's check the second inequality. Instead of an A, I'm going to plug in a 3. Instead of C, I'll plug in 2. So I have 75 times 3 minus 1 plus 50 times 2. Well, 3 minus 1 is 2, and 75 times 2 is 150. And of course, 50 times 2 is 100. So 150 plus 100 means he'll make $250 off of that trip, which is greater than or equal to 150. So it's a solution for the second inequality as well. So yes, this is a solution of the system of linear inequalities because the number of adults and children results in a true statement for both inequalities. It worked for both of them. How'd you do with B? So again, we have our system of inequalities here, yay, from our getting started activity. And remember, A does not equal 5. Chase is in the boat too. So Chase is guiding 5 adults, which means that A equals 6. And of course, C equals 0. There's no kids this time around. So again, I'm going to plug in for A, I'm going to plug in for C. So 200 times 6 plus 100 times 0. Well, 200 times 6 is 1,200. 100 times 0 is 0. So we have 1,200 pounds in the boat. That is not less than or equal to 800. That's not good. Let's check the second inequality. Plug in an A, plug in a C, plug in 6 for A, plug in a 0 for C. So I now have 75 times 6 minus 1 plus 50 times 0. Well, 6 minus 1 is 5, and I've grabbed my calculator over here. 75 times 5 is 375. Make a little note there. And of course, 50 times 0 is 0. So he would make a lot of money. $375 is definitely greater than or equal to 150. But he's over the weight requirement. So no, this is not a solution to the system of linear inequalities because it does not satisfy the inequality representing the weight requirement. I mean, it's great that you make some extra money, but is $375 really worth it if everybody on the boat drowns and dies? I'm just saying, you're over the weight limit. You can't be doing that. That's dangerous. Let's go ahead and come over here. We're going to graph the next step. We're going to graph our system of inequalities. Here's our system. If you're a little confused because we've got X's and Y's and they have A's and C's, just real quick, our adult rafters is our X. So if you want to, you could be like, that's A. And our child rafters is our Y-axis. So if you want to, you could be like, hey, that's C. If that helps you out just a little bit. So if you want to, you can, instead of an X, you can make that an A. Instead of a Y, you can make that a C, if it makes it easier for you to figure this out. So don't panic, don't panic. You know how to graph inequalities. You did this last time. So you're going to graph the first inequality, straight line, solid line or dashed line, shade your half plane, then do the same thing for the second one. Solid line or dashed line, shade the half plane, and keep in mind, because you're doing them both on the same graph, I really encourage you to use colored pencils, like to use a different color for each one. That will help out. If you don't have different colored pencils, don't panic. Often what I will do is because I'm just using my little gray pencil, I will often shade the first one horizontally, like I'll shade side to side. And then the second one I'll shade vertically, like I'll shade it up and down. So that way I can tell which is which, just helps my brain out a little bit. So go ahead, take your time there, hit pause, graph each of these inequalities, and then go ahead and hit play when you're ready to check your work. So I'm going to start with this first one. Let's see what I got here. There it is. I'm going to start with this first guy right here. Probably the easiest way to graph these will be to find the x-intercepts and y-intercepts. Or in our case, we'll find the a-intercept and the y and the c-intercept. Would that work? Something like that. We'll make it work. Remember that when you're finding your intercepts, you're just plugging in a 0 for the other variables. So for my a-intercept, I'm going to be like, hey, c equals 0. So 200a plus 100 times 0 equals 800. And of course, that means you have 200a equals 800. And if you divide both sides by 200, you discover that a equals 4. So I should have an a-intercept at 4, a-intercept, x-intercept, whatever we call it. So we'll put a little dot right there. That means for our y-intercept or our child intercept, sorry, sounds sketchy there. We do want to set a equal to 0. So I'm going to say 200 times 0 plus 100 times c equals to 800. So we can get our boundary line going here. Of course, 200 times 0 is 0. So I don't have that anymore. And if we divide both sides by 100, we find that c equals 8. So it looks like I should have a y-intercept or a c-intercept at 8. So I'm going to go ahead and put a little space that little dot right there. Sorry, it's kind of off. Now, please remember when you connect the dots to make sure you pay attention to whether your line is your boundary line is dashed or solid. I see a squashed equal sign, so I'm like, hey, it's solid. Solid as a rock. So I pop that in there. Now, last but not least, for this first one, we need to figure out which side it's shaded on. We said usually I like to pick 0, 0, right? If I pick 0, 0, plug in 0, 0, and it's true, I'm like, yay, I shade that side. If I plug in 0, 0, and it's not true, I shade the other side. So I'm going to plug in 0, 0. So that means I have 200 times 0 plus 100 times 0. We want to know if that's less than or equal to 800. And of course, 200 times 0 is 0. 100 times 0 is 0. 0 plus 0 is 0, which is definitely less than or equal to 800. Yeah! So I'm going to shade this whole side. Check it. Whoa! So I shaded this whole side. I went ahead and did it horizontally. I told you guys I like to do the first one horizontal, just so I can go vertical on the second one. So shaded this whole side. Yay! Wasn't that exciting? It was very thrilling. Let's now take a look at that second inequality. So again, let's find our A-intercept, right? Where we're like, okay, C equals 0. So 75 times A minus 1 plus 50 times 0 equals 150. So we can find our boundary line. Of course, I can distribute the 75, so I'm going to do that. So I have 75A minus 75. 50 times 0 is 0, so that's gone. And you guys know how to do this, right? Add 75 to both sides. Choo, choo, choo. And I have 75A equals 225. And if I divide both sides by 225, hang on here, I got my trusty calculator. So if I divide 225 by 75, I get 3. Choo-choo. So it looks like I'm going to have a x-intercept of 3, right? So I'll have a dot. I'm going to put it there. Have a dot right there. There it is. Sorry, you can't see it too well, huh? So make it a little. There you go. Is that better? Sort of. There we go. There's my dot. So there's my A-intercept of 3. And of course, we need to find the C-intercept as well. So let's go ahead and find the C-intercept, because we need to find that guy too. So that means I'm going to plug in a 0 for A. So I have 75 times 0 minus 1 plus 50. C equals 150. I'm running out of space. Of course, 0 minus 1 is a negative 1. Negative 1 times 75 is negative 75. And that means I need to add 75 to both sides. I feel like I've done this before. If I add 75 to both sides, I get 225. And if I divide that by 50, I get 4.5. So it looks like there's 4, there's 5. So right in the middle there, right in the middle again. Sorry, it's kind of hard to see. I'll kind of see if I can make it a little darker. A little darker, something like that. There you go. Not perfect, but you get the idea. Oh, and once again, I do see a squashed equal sign. So that means this line is also, ooh, sorry. Oh my goodness, my eraser. I need the eraser, it went crazy. So that means, since I have a half equal sign down here is equal to, that means I'm drawing a solid line. I'm going to connect these guys up with a nice solid line. Now, last but not least, we need to figure out which side of this line we have to shade. So I'm going to plug in a 0, 0. If I plug in a 0, plug in a 0 for A, plug in a 0 for C. But we want to know if that's greater than or equal to 150. 75 times 0 minus 1 is negative 1 times 75 is a negative 75. Of course, that's gone. That's a 0, right? And negative 75 plus 0 is negative 75, which that's not greater than or equal to 150. So no, dude, that side's not shaded. The 0, 0 is not shaded. Okay, so because the 0, 0 side isn't shaded, I need to shade the other side. So again, I did my up and downy shady. I used a slightly different color as well, all that good stuff. Now take a look. There's this little like sliver in the middle here where they overlap. Do you see that? In fact, here, maybe this one's a little easier to see. We have this little like slice in the middle where our two shaded portions overlapped. Interesting. It turns out the solution of a system of linear inequalities is this intersection of the solutions to each inequality. So it's where the two shaded bits overlap, all right? We say intersection, maybe you prefer the word overlap, all right? So it's where my two shaded guys overlap. That's where all of my solutions are. Yeah, every point in the intersection region, every point inside this little sliver we've got where they overlapped satisfies both inequalities in the system. If you were to pick any point in this little slice, that point should be true for both the first and second inequalities because that's where the shady bits overlap, right? So cool. You now know where all of your solutions are. That's right. So can you give me, just answer a couple questions here for me. On question number 3, I got a whole bunch of questions for you. You're going to want to look at your graph. You may have to flip back and forth. And of course, I also have my graph on the screen to help you out. But can you do parts A, B, C, and D? I know I only have A on the screen right now. But can you do all of number 3, parts A, B, C, and D? You're going to want to read the directions carefully. So go ahead, hit pause, work your way through all these guys, and then hit play when you're ready to keep the discussion going. All right, part A, my little sliver here. Describe the possible number of solutions for a system of linear inequalities. Well, these arrows go forever, don't they? I mean, they go forever and ever and ever. So that means my shaded bit, my shady sliver is going to go like forever and ever and ever up with it also, isn't it? So what this tells me is that I might possibly have an infinite number of solutions. The system of inequalities can have many solutions as long as those half planes overlap. As long as those half planes overlap, we can have a heck of a lot of solutions, just so long as they overlap. Is the intersection point to the system, pardon me, I can say this, is the intersection point a solution to the system of inequalities? So this little point where they meet up, is that a solution? Why or why not? Go ahead and hit pause, jot down, you've already hit pause and jot down your thoughts. Let's talk about it. So this little intersection point, you know, we said when the lines are solid, we mean that the line is a possible solution, right? Line contains solutions. When the line is dashed, it's not equal to, and so any point on the line can't be a solution. Well, these are both solid lines. These are both equal to. So yeah, that intersection point down there can totally be a solution to this system of inequalities. So while the intersection point is a solution to the system of inequalities, the other thing you want to keep in mind is it doesn't actually make sense in this problem situation. Look at this point. What is that point? It's like, it has like negative children, right? And it's like 7 adults, but like -6 children. So yeah, it's a solution, but it actually doesn't make a lot of sense. So yes, technically it is a solution to the system of inequalities, but it doesn't make sense in the problem situation because you'd have to take 7 adults and -6 children. I'm not sure what -6 children looks like. Generally, I like to think children are positive. I mean, I guess they can be mean sometimes, but that still doesn't make them negative. Come on now. I hope you did this next part. Identify 3 different solutions of the system of linear inequalities you graphed. What do the solutions represent in terms of the problem situation? So that you could have picked any points in your sliver, any points in that overlap, those would be solutions. So I picked a couple points. You probably picked different points than I did. Maybe you picked the same points. I don't know. So I picked the 0.22. I was like, that's inside, yay. And then I went further and I was like, I'm gonna pick the 0.23. That's inside as well. And then I was like, I'm gonna go crazy. And I picked the 0.31. It's inside, great. Those are all inside of it. And so what do they represent? Well, this means I can take 2 adults and 2 children. I can take 2 adults and 3 children. I can take 3 adults and 1 child. So these are all possibilities. You can see there are clearly some other possibilities, but these are the ones I picked. Can you did you determine one combination of adults and children that is not a solution for the system of inequalities, and explain why? So you could have picked any point not in your little sliver and it would not be a solution to the system. So I picked the point, what point did I pick? I picked the 0.21. You can see it's just outside of it. You could have picked a different point that would have been fine, but I said the 0.21. First of all, it's outside of my sliver of my overlap, so I know it's not a solution. But we said it does not represent a solution because Chase, 1 other adult, and 1 child would earn him less than $150. It doesn't earn him enough money. So it's not a solution. Boo. Let's go on then to activity 4.2. So now we've got this figured out. Now we're like, okay, we need to graph both sides. We need to graph both inequalities, and we look at where they overlap. And where they overlap, that is my solution, right? That's our deal. So that's what you're going to do. You're going to determine the solution set of the given system of linear inequalities. So this is just a bit more practice, getting used to it with what we did earlier. And fortunately, these equations are a little nicer than what I just gave you before. So I would like you to start off by graphing the system of inequalities. We're going to take you through step by step, all right? So graph the system of linear inequalities. Go ahead and hit pause to graph both of these, and then hit play when you're ready to check your work. Apparently they're playing with the PA system in here. All right, let's graph these bad boys. There's a lot of ways you could do this. I'm going to go ahead and do the whole x-intercept, y-intercept thing. That's fine. So for my x-intercept, I'm going to say y equals 0. So x plus 0 equals 1, which means x equals 1. Yay! So my x-intercept is 1. Let's find the y-intercept. So we'll say that x equals 0. So 0 plus y equals 1, which means y equals 1. Yay! So I have hang on, there it is. My y-intercept is at 1. Huzzah. No squashed equal sign. No squashed equal sign, which means this line be dashed. That is a dashed line. So I'm going to dash it. Dashed. Isn't it pretty? It's so pretty. I love technology. I can make it all pretty. I need to know which side to shade. So again, I like to plug in 0, 0. So I'm going to plug in 0, 0, and I'm going to be like, dude, are you shaded? So 0 plus 0, is that greater than 1? Well, 0 plus 0, 0, which is not greater than 1. So not shaded. So since 0, 0 is not shaded, I'm going to shade the other side. I'm going to shade this side over here. I can't shade the side with 0, 0. We know that's not correct. So I shaded the other side. Again, I did it horizontal. Again, I used a nice yellowish color. I think it's supposed to be orange, but that's not orange, is it? I don't know. Blame the computer. Let's take a look at the second inequality. So fine, we'll start with the x-intercept. I'm going to plug in y equals 0. So negative x plus 0 equals 3. So negative x equals 3, which means x equals negative 3. So that means I have an x-intercept at negative 3. So back over here, there it is. Let's now find our y-intercept. I'm going to plug in a 0 for x. So negative 0 plus y equals 3. It means y equals 3. I didn't even know it. There's no such thing as negative 0. 0, 0, 0, people. Oh, so my y-intercept is at 3. So 1, 2, 3. Pop that up there. There we go. Sorry, it's a little off, isn't it? My bad. And, check that out. There's a squashed equal sign. That means that this line is solid. solid as a rock. Your parents will get it even if you don't. So here's my nice solid line. It is a nice solid line, so solid. And I don't have arrows on here. I should have arrows on the end of these guys, right? I mean, really, these should have arrows. I feel like that's a thing that should happen. So it's happening. Oh, and I need to figure out which side to shade, right? Oh, I knew I was forgetting something. I got to figure out which side to shade. So let's see. Here's 0, 0. Here's 0, 0. So it's going to tell me if I should shade under, if I should shade over. So let's plug it in. -0 plus 0 less than or equal to 3. Well, 0 plus 0 is 0. And that is less than or equal to 3. So, hey, there we go. That's true. So that means 0, 0 is in the shaded part. So I'm going to go ahead and shade this underside of my solid line. And I used a slightly different color, right? All that good stuff. Now, again, we said our solutions are in the overlap. So our solutions are going to be in this chunk right here. That's a big chunk. I ain't a sliver this time. This is a big, big chunk. And you can see we've kind of created 4 sections of this, haven't we? We have a region that's just true for the first inequality. We have a region that's just true for the second inequality. We have a region that's not true for any inequalities, either inequality. And then, of course, these are our solutions. Here we have solutions. These are the guys that are true for both inequalities. So what I would like you to do is you're going to want to use this graph. And on question number 2, and again, sorry, I know you're going to have to flip back and forth a little bit. You're going to choose a point from each region of the graph. Now, I already picked one for you. So you can see they already did one, -8, 2, right? So we already picked, let me come back here. Whoa. We already picked the point -8, 2, which is, -8, 2, there it is. So -8, 2, which is out here. Now you can already see it's not a solution to either one because it's not shaded. But I would like you in the table to do the math, okay? So we took that -8, 2, we plugged in a -8 for x, we plugged in a 2 for y, and we're like, -6 is not greater than 1. So we know it's not a solution for the first one. Plugged in a -8 for x, plugged in a 2 for y, double negative makes that a positive 8. 8 plus 2 is 10. 10 is not less than or equal to 3. Boo! So we can see the point is not a solution to either inequality, and it's located in the region that's not shaded by either inequality. So we've already picked a point from this region. I want you to pick a point from the upper region, from the region on the right, and from the region on the bottom. Pick a point from each of those regions, pop it into your table, plug it into your equation, your inequalities to see what happens, and then give me a nice description of what's going on at the end. Go ahead and hit pause, work these out, and then hit play when you're ready to keep this discussion going. Now, I'm going to point out you probably picked different points than I picked, but that's okay. I'm going to pick a point up in this region, like this point. This point looks good. This point looks good. That's what? -1, 5. So I'm picking -1, 5. So we already did -8, 2. I'm going to pick this point, -1, 5, and let's see what happens. I mean, I can see it's only shaded by the first inequality, but let's go ahead, do the work, see what's going on. So I picked -1, 5. I'll plug in a -1 for x and a 5 for y. Of course, -1 plus 5 is 4. And 4 is greater than 1. Yes, it is. So cha-ching, that's a good sign. So it does work for that first inequality. Let's go ahead and plug into the second inequality. So -x means -1 plus y means plus 5. Of course, -1, that becomes a positive 1. So I'm like, that's a positive 1. And 1 plus 5 is 6. 6 is not less than or equal to 3. That didn't work. But we kind of knew that was going to happen. So it looks like the point is a solution for the first inequality, but not the second. And it is located in the region shaded by the first inequality. All right. The next point I picked, let me come back over. I'm going to come back over here to my graph. The next point I picked, what did I pick? I want to say I picked 3, 1. I was like, that sounds good. Over 3, up 1. Whew. So I picked this point. I got this lovely point here, 3, 1. So I picked a point in this region off to the right. Let's go ahead. Oh, sorry, I got to bring back all my guys. There we go. Let's go ahead and plug it in, see what happens. Plug in a 3 for x and a 1 for y. Well, 3 plus 1 is 4. That is greater than 1. Yay! So it works for our first inequality. For our second inequality, that's a negative x, so that'll be a negative 3 plus 1 for my y. Negative 3 plus 1 is a negative 2. And negative 2 is less than or equal to 3. So check it out. It worked for both inequalities. This point is a solution for both inequalities. It's located in the region shaded by both of them. So we knew it was in the region shaded by both, so it makes sense that it is a solution for both inequalities. We should not be surprised by this at all. And of course, let's come on back to our graph one more time. Oh, well, come back to our graph one more time. I need to pick something in this region. I'm going to pick this guy right here. Sounds good. It looks like there's no, if I pick that, there's no x coordinate, 0, and we just went down 3. So it looks like I have a point at 0, negative 3. Again, you may have picked a different point in this region. That's totally fine. That's totally okay. Your points may be different than my points. As long as you picked a point in the region, we're pretty good. So when I picked 0, negative 3, that means I have 0 plus a negative 3, which is negative 3. Negative 3 is not greater than 1. That's no good. Let's take a look at our second one then. Negative 0 plus a negative 3. Well, negative 0 is 0, and negative 3 is negative 3. Negative 3 is less than or equal to negative 3 is less than or equal to 3. So I'm going to be like, good job, well done. So as you can see, the point is a solution for the second inequality, but not the first. And it is located in the region shaded by the second inequality, right? It was in the green only region down the bottom there. So let's take this a little further. We did have one solid line and one dashed line. So Alan makes a statement about the intersection point of the system of inequalities. So where the boundary lines intersected. And Alan says the intersection point is always a solution to a system of inequalities because that is where the two lines meet. Alan's wrong. Why? Go ahead and hit pause. Write down why Alan is wrong. Incorrect. We'll say incorrect. And then hit play when you're ready to continue the discussion. So guys, Alan is incorrect. Alan's incorrect because the intersection point isn't always a solution to the system of inequalities, right? The intersection point for our system, and I'll come back here to the graph real quick. Oh, we go back and forth so much. The intersection for this guy was at negative 1, 2, right? You can see there's our intersection point. The problem is, while it's true for the solid guy, we know it's not a solution for the dashed line. So Alan, you wrong, buddy. The intersection point for the system, negative 1, 2, it only works for one of the inequalities, not both of them, which means it's not a solution. If the inequality symbols are not both equal to, then the intersection point's not going to be a solution, right? We said it has to work for both. If it doesn't work for both, it's out. All right, we have just a few more, just two more problems before we're going to call this one done for the day. All right, so we have two systems of linear inequalities. You've been doing this for a little while now. You're getting more used to it. And in fact, you'll notice these ones are a little bit easier to graph as well. So it should be kind of nice. So I would like you to solve each system of linear inequalities by graphing the solution set. So for part A and part B, I would like you to do both of these. Now, once you've graphed them, you've solved it, you're like, that's my overlapping region. Then I'd like you to identify 2 points. Pick 2 points that are going to be solutions of each system. So part A and B, do each one of these. Go ahead and hit pause to work these out, and then hit play when you're ready to check your work. All right, let's do this thing. Sorry, that's really annoying, isn't it? All right, first of all, this is actually pretty easy to graph because they have it like all like in this form. So the boundary line in slope-intercept form, that's super easy. My y-intercept is 3, so I'm going to put a little dot on 3. My slope is 5, so remember that means 5 over 1. So we're going to have to go up 5, 1, 2, 3, 4, 5, and over 1, and I'm going to make my next dot right there. Now, notice no equal sign. So this bad boy is dashed. So I'm going to dash it. Whew, there we go. We need to figure out which side to shade. So again, I like to pick 0, 0. If 0, 0 is a solution, we shade that side. If it's not a solution, we shade the other side. So I'm going to plug in a 0. So 0 is greater than or equal to 5 times 0 plus 3. So that's 0. 5 times 0 is 0. 0 plus 3 is 3. Hey, 0 is not greater than 3, so 0, 0 is not shaded. Boo. That's fine. We still get a shade. We're just going to shade the other half. So instead of shading this side, I'm going to shade that side. So pretty, my horizontal shading. Let's do the other inequality, shall we? Because again, we want to see where they overlap. Where they overlap, that's where our solutions are. So I'm going to shade this other guy here, which means, let's see, I've got y equals 5x minus 3. So I'm going to have a y-intercept at negative 3. So I'm going to put a little dot there. I have a slope of 5. Remember, that's 5 over 1. So again, I'm going to go up 5. 1, 2, 3, 4, 5. I'm going to go over 1, and I'm going to put a little dot right there. Once again, that bad boy is also dashed. There's no half equal sign. So I'm going to make a nice dashed line through here. And of course, is 0, 0 a solution? Well, we're going to find out. In fact, hang on a minute. I'm going to write it over here. So let's find out if 0, 0 is a solution, shall we? 0, 0. So if I plug in a 0, is it less than 5 times 0 minus 3? We're going to find out. 0, let's see, 5 times 0 is 0. 0 minus 3 is negative 3. 0 is not less than negative 3. So again, not shaded. Wow. 0, 0 is getting no love today. So here's my dashed line. 0, 0 is on this side, but that means I need to shade the other side. So I shaded the other side. Uh-oh. They don't overlap. Oh my gosh, there's no overlap. What does this tell us? What does this tell us? What does this tell us? You're smart, right? So we see that they don't intersect. Hang on, I'm gonna erase all my ink here. They don't intersect, So what does this tell us? There's no solutions. What? There's no solutions for these inequalities. They don't intersect. There's no overlap. If there's no overlap, there's no solutions. I guess I'm not identifying 2 points that are solutions then. All right. How'd you do on the other one? Was the other one a little trickier? It's not that bad. Let's start with this first one. I can see I've got a solid line going here because of that little half and equal sign. X, and again, my boundary line then is going to be x equals negative 5. All right. So here is where x equals negative 5. So I'm going to put a dot right there. And we're just going to make a solid line right through it. Whoa, sorry, my solid line's a little off. This says that x is greater than negative 5. So instead of using 0, 0, I'm going to cheat just a little bit. This says that x is greater than negative 5. You know, greater than is everything to the right. So I shaded it to the right. There we go. Let's do something similar for this guy. We can see that the second one is also solid, right? I mean, he's solid. He's got a little half and equal sign down there. And we're going to graph the boundary line at x equals 1. We'll make a nice solid line there. So x equals 1 is over here. That's where x equals, Miss Scott. That's wrong, isn't it? Hang on. I messed it up. That's okay. We're going to do it by hand then. So here we go. Here we have x equals 1. There's my lovely line. Sorry, I did a bad job there. And of course, we said it's going to be a nice solid line. Oh, this is going to be my worst line ever, but we're going to go ahead and make a nice solid line. You get the idea. There's my really bad solid line, but there it is. And of course, we are going to shade. So let's figure out which way to shade here. It does say X is greater than 1. Okay, so greater than is everything to the right. So again, I'm going to shade everything off to the right. Coloring. We're coloring. Yeah. Not bad. Not my best, but not bad. That's fine. There's a lot of overlap happening here, isn't there? There's a lot of overlap happening here. Now, again, so there's a lot of overlap. Basically, everything greater than 1 is in the overlap, isn't it? Everything greater than or equal to 1 is in our overlap. So I want my pen back. I want my red pen back. So we want to identify 2 points that are solutions of the system. Basically, I can pick anything over here, anything I want, right? Like I can pick this point right here. That sounds like a good point. 2, 0, that's a solution. It's in an area where they're both shaded. Shoot, I can pick this point. I can pick a point like out here, dude. I can pick this point if I wanted to. That sounds like a point. It's in the area where they're both shaded. So what is that, 5, 5? Yeah, 5, 5. Okay. So 5, 5, that's going to be another point. Whoa, that's going to be another one of my points. 5, 5. These are both solutions because they're both in the overlapping shaded area. It's always the overlap. So this one was a little funkier, but at least it had an overlap this time and it didn't do that whole no solution thing like the last one did. It was kind of a jerk move. Let's be honest about that. As always, guys, I hope you found this helpful. I hope you found this useful. I hope you found it entertaining when I made mistakes. As always, if you need anything, let me know. Talk to me during class. Come see me during office hours. Whatever it is you need, I'll help you guys out. And I'll see you soon. Bye.